Here are some examples of problems about solving trigonometric equations. Problem 1. Find all solutions of 2 cosine theta minus 1 equals 0 for 0 less than or equal to theta less than 2 pi. To solve this equation, let's first try to isolate cosine of theta. Starting with 2 cosine theta minus 1 equals 0, we can add 1 to both sides of the equation to get 2 cosine theta equals 1. And then divide both sides by 2 to get cosine theta equals 1/2. Now if we draw a graph of both of these expressions, where this axis is theta and this is y, cosine theta will look like this between 0 and 2 pi. Here's 0 and here's 2 pi, while 1/2 will be a line like this. We can see that in this interval there should be 2 points of intersection, here and here. We also know that cosine of pi over 3 is equal to 1/2, and that cosine of 5 pi over 3 is equal to 1/2. So the two solutions are theta is equal to pi over 3 and 5 pi over 3, at least on this interval. Problem 2. Solve the equation sine theta equals cosine theta for all values of theta. Starting with sine theta equals cosine theta, let's square both sides of the equation. This will give us sine squared theta is equal to cosine squared theta. Now let's subtract sine squared theta from both sides of this equation. This will give us 0 on the left-hand side, equal to cosine squared theta minus sine squared theta. But this expression is a familiar one. We know that this is equal to cosine of 2 theta using the double angle formula. Now that we have this new equation 0 equals cosine of 2 theta, let's draw a graph to see where our solutions should lie. This is the theta axis and this is the y-axis. It'll look something like this, except it's cosine of 2 theta instead of cosine of theta, so the period is going to be pi instead of 2 pi. So this will be at pi. This graph shows us that there should be 2 solutions between 0 and pi, one here and one there. Now we know that cosine of pi over 2 is equal to 0, and also that cosine of 3 pi over 2 is equal to 0. Now divide each of these angles by 2, we'll figure out which values of theta solve the equation 0 equals cosine of 2 theta. So theta is pi over 2 divided by 2, which is pi over 4, or 3 pi over 2 divided by 2, which is 3 pi over 4. Since the period of cosine 2 theta is pi instead of 2 pi, to find the values of theta between 0 and 2 pi, we can add pi to each of these. This gives us 5 pi over 4 and 7 pi over 4 as 2 more solutions. However, notice that in the first step, we squared both sides of the equation, which could have gotten rid of minus signs. This means that we might have extraneous solutions, so let's check for those. At theta is equal to pi over 4, we have sine and cosine of theta both equal to square root 2 over 2. But at 3 pi over 4, sine theta is root 2 over 2, which is not equal to minus root 2 over 2, which is cosine theta. Then for 5 pi over 4, we have minus root 2 over 2 and minus root 2 over 2 for sine and cosine of theta, which is good. And then finally, for 7 pi over 4, sine theta is equal to minus root 2 over 2, which is not equal to root 2 over 2, which is cosine theta. This means that 3 pi over 4 and 7 pi over 4 are not actually solutions to the original equation. This leaves us with theta is equal to pi over 4 plus 2 pi n, or 5 pi over 4 plus 2 pi n. And we can write this even more simply as pi over 4 plus pi n.